Okay, so the next task up for bid on today's Math is Right is finding the equation of the tangent line. So, we know how to deal with the equation of a line. Remember, we need two things. We need the slope and we need a point that the line goes through. Well, let's take a look at number 20. Okay, here's the point that the line's going to go through. We just need to find the slope of that tangent line. So let's go back to that other thing we worked on is here. So okay, so again, here was the slope of this line. I'm not going to go through the whole thing and everything like that. So, by the way, this line that goes through the 2 points, secant line. Remember, secant on a circle, cross the line or intersect the circle in 2 points. Well, this line intersects the graph in 2 points. Now, when we say 2 points or 1 point, what we'll do is we try to think in the small neighborhood, because we can have a line intersecting it like one spot over here, way over to the other side. We don't care about that. Just in the neighborhood. And again, this neighborhood where h is 1. So, okay, that's still a secant. By the way, remember what a tangent did? Intersected the circle how many times? Exactly. So here is the tangent line to that graph through this point A, f of A. So what can we do to get this line? We know that point A, comma f of A, that 1, 1. But how can we get the slope? Well, let's see what happens as we draw the h getting closer, approach that h closer to 0. Look at that line, the secant line. It's all of a sudden goes from this side of the way over here. It's starting to close in onto that tangent. Closer, 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 and all of a sudden, ta-da! It is the tangent. So as that rate of change, that slope, becomes h approaches 0, that line approaches the tangent. Again, we can't find the slope at 1 point. We need 2 points. What 2 points? Well, the 2 points as h approaches 0. That's right. Another limit. Not just another limit, that same limit we did before. So the slope for the tangent line is the limit as h approaches 0 of f of x plus h minus f of x all over h. Now, we could use a like we did before and go ahead and do that. A would be your x value, which would be in this case 1, in number 21, negative 1. But let's do this with just plain old x in here and see what happens. Okay, so over here, let's look at number 20. Let's find the slope of that tangent line through 1, 1. Now, why do we want to do it with sometimes with 8x instead of a? At one point, it don't matter. But there's going to be points and times we're going to need to find that tangent line to be special. For example, if we go back to here, and I'll take that secant out, at what point will that tangent line, this tangent line here, be horizontal, or in other words have a slope of 0? Notice how that, oh wait, yeah, so we can find that value. It's right about anyways, you get the idea. It's right in that neighborhood, right close to there. So how are we going to do that? Well, we need x, not a specific a value, because we don't know what that a value is. So let's use this right here. So I'm going to skip that first step we were doing before. We're plugging, actually just rewriting it. So limit as h goes to 0 of f of x plus h. So plug in x plus h for x minus 1. That parentheses isn't necessary, but sometimes showing that, okay, this is f of x plus h minus, well, f of x. Well, plug x for x. Well, that of course doesn't do much. This parentheses is necessary. Again, I'm telling you right now, this slope of the tangent line, this here, that instantaneous rate of change is always 0 over 0, or that indeterminate form. So don't bother with direct substitution. We know that works. With that, okay. Again, x plus h squared. Just, I know I skipped over it before. Remember, x plus h squared, or the quantity, means you're doing this. So you'd end up with x squared, x times h, and another x times h, so there's two of those, and then h squared. Skip that, I skipped going through that algebra before. I just decided that we'll do 2 this time, and then it's 2 times all that. Now, if required is what you see in front of you, necessary, it's up to you. And then so that's minus 1. Now I'm going to take that minus the 2x squared minus the negative 1 and combine like terms. So 2x squared minus 2x squared, we get a 4xh, 2h squared minus 1 plus 1 all over h still. Now you can definitely see the 0 over 0, but again, since you can see it, you can notice, bye bye h, common factor of h. Now plug in 0 for h to evaluate that limit, so 4x plus 2 times 0 is 4x. So the slope of any line tangent to this curve is 4 times whatever the x value is. So now, what's the slope at x equal 1? 4. Now, recall, go back, think. So, how do we write the equation of any line? Slope, if we use point slope form, which I suggest, y minus the y coordinate equals the slope, x minus x coordinate. And so for here, we go y minus the y coordinate of the point, 1, equals the slope, times x minus the x coordinate, 1. And we are done here. You don't have to put it in the slope intercept form. You don't have to do anything. That is fine and dandy. Okay? So, doesn't matter if it's like this, you do the same thing. So now if for some reason, let's say I wanted, what's the slope of the tangent line at x equals 3? Or at x equals 0? Or something like that. Or if I wanted to say, when is the slope equal to 0? Horizontal tangent. Now I could just set that slope, that 4x equal to 0, and do a whole bunch of other different things with it. So that's why we want to do it this way, with the x. Okay? So, it's the same limit over and over and over again for these. Okay? As of now.